Now we're going to take a look at how to find whether or not a graph has a hole. Factor numerator and denominator and set any common factors equal to 0. That is where our holes will occur. So our numerator is the difference of squares. And we've got a common factor of x minus 3. Set that equal to 0. So at x equals 3, there would be a hole in the graph instead of a vertical asymptote like we saw in the first video. Let's look at that one more time with b, factoring our denominator, what multiplies to negative 8 and adds to positive 2. So we've got a common factor of x plus 4, set that equal to 0. So there would be a hole in the graph at x equals negative 4. Last piece, we're going to kind of put it all together. So we're going to have to follow the steps for the vertical asymptote, horizontal asymptote, holes, and domain restrictions. And then tomorrow, like I said, we're going to learn how to put it all together as a graph. All right, so I like to start with the domain restriction, vertical asymptote, and holes. I come back to the horizontal asymptote because that's kind of a different piece than the other ones. So setting my denominator equal to 0, x cannot equal 1. For a vertical asymptote, in case it's a hole instead of a vertical asymptote, I'm going to go ahead and factor. There are no common factors, so we have no holes, but we do have a vertical asymptote at x equals 1. Domain restriction, we got zeros, so we're going to set the numerator equal to 0. So x equals 3 would be the root or the 0 where the graph crosses the x-axis. And then finally, the horizontal asymptote. So this is where we look at the degree of the numerator and the degree of the denominator. So the degree of my numerator is 1, and the degree of my denominator is 1. When the degrees are equal, we use the lead coefficients. 4 over 1, or 4. Y equals 4 would be my horizontal asymptote. Just double checking to make sure I didn't miss anything. And as I mentioned, we have no holes, so you could just make sure that we have all of our bases covered. Last example. Domain restriction, x cannot equal 1. It does not matter if there is a common factor of x minus 1, that is still a domain restriction of our function. It's either a vertical asymptote or a hole, but x cannot equal 1. And in order to figure out which it is, I'm going to go ahead and factor my numerator. What multiplies to negative 15 adds to positive 2. Positive 5, negative 3. So it does not cancel, so that means it's a vertical asymptote. Which means there are no holes, because we have no common factors. 0, setting the numerator equal to 0. We would cross the x-axis at negative 5 and positive 3. Finally, looking at any horizontal asymptotes, the degree of the numerator is 2, the degree of the denominator is 1, and when the degree of the numerator is greater than the degree of the denominator, there are no horizontal asymptotes. You try.